Hello, welcome. Let's look at the electronic configuration of the first transition series. The element argon at the end of the third period has the electronic configuration represented as 1x2, 2x2, 2p6, 3x2, 3p6. The next two elements in the periodic table, potassium, calcium, have electrons in the 4s orbital, not the empty inner 3d orbital as might be expected. The 4s orbital is lower in energy level than the 3d orbitals. Once the 4s orbital is full, electrons are then added to 3d orbitals. Both potassium and calcium have the following structures respectively. K, potassium is 1x2, 2x2, 2p6, 3s2, 3p6, 4x1, while calcium is 1s2, 2x2, 2p6, 3s2, 3p6, 4x2. After these two elements comes scandium, which is the starting of the first transition series elements. Electron goes to the first of the 5 3d orbitals because 3d orbital is lower in energy than 4p, which should have been the next orbital. The electronic structure of scandium is 1s2, 2s2, 2p8, 3s2, 3p6, 3d1, and 4s2. So this is simply explaining to us that when you look at these other elements that are not in the first transition series, you will not see this 3D one or this 3D. This 3D is 3D orbital is very common with the first transition series elements like scandium and the ones we've already mentioned. So this makes them to behave differently from every other elements like potassium and calcium and other ones. So take note of these 3D orbitals in first transition series. Now let's look at variable oxidation states, which is a very important property or characteristics of first transition series elements. There is very little difference in energy between the 3d and 4s electrons. The elements can easily lose electrons from 3d and 4s orbitals so that they can form compounds with a number of oxidation states. For example, manganese with the following electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s2, can lose 4s electrons to give a plus 2 oxidation state, as in manganese 4 oxide, 2 4x and 2 3d electrons to give 4 oxidation states, as in manganese 4 oxide. Okay, this manganese 2 oxide, this manganese 4 oxide, or 2 4x and 4 3d electrons to give a 6 oxidation state, as in manganese 4 oxide. Okay, manganese oxide, manganese 2 oxide, manganese 4 oxide. Okay, this is manganese 2 oxide because of these two oxidation states, manganese 4 oxide because of these 4 oxidation states, and manganese 6 oxide because of these 6 oxidation states, and 5 3d electrons to give 7 oxidation states. So we can lose from either the s or d orbital making it to have variable oxidation states. Another very important characteristic of transition elements is their ability to form complex ions. This is another feature of ions of the metals of the first transition series. They have a very good tendency to form complex ions. A complex ion has a central positive ion linked to several other atoms, ions or molecules called like ligands. The bonding between the central ion and the ligands can form a coordinate bonds to the metal ion. The ligands donate electrons to the empty d orbital of the metal ion. Example is ion 3 ion, which is surrounded by 6 water molecules. This dispose octahedrally round the ion to give this hydrated ion. Each water molecule uses a lone pair on an oxygen to form a coordinate bond to charge, e.g. ion and CO3 ions form complex ions that are more stable than those of ion and CO2 ions. That's CO with double oxidation state ion. Now, formation of colored ions. Transition elements also form colored ions. The transition metals give colored ions because of the presence of their unpaired 3d electrons, that is 3d1 to 3d5. Zinc and scandium ions are colorless because they do not have partially filled 3d orbitals. Then another important property of transition metals is their ability to form alloys. Now, alloy steels. These are made by adding other metals to the steel to form alloys. Stainless steel is obtained by the addition of chromium and nickel. It is used for making cutleries, scissors, saws, and machinery. Cobalt gives a highly magnetic steel used for making permanent magnets. Tungsten gives very hard steel for making cutting and drilling tools. Manganese gives manganese steel that are hard and tough and used in rock drills. Silicon gives spring steels and molybdenum gives molybdenum steel. So these are the ways that you can use transition first transition series elements. You add it to iron and form different alloys that can be used for different things. Please, if you like this, hit the subscribe button. That is where we are stopping for today. Next classes we'll be looking at organic chemistry and others. Thank you. God bless you.